Welcome to this video on maths and memory, and here we're going to deal with basic percentages today. We're going to deal with this grade 4 topic. It's a bronze tier topic on this video, and it can be found in both foundation and higher tier topics. So let's get a revision card. Let's call this the Master Maths Memory card, where we have the main, let's say, learning objectives and key features of this video. Let's call this the learning objective box, and let's run this 3 clear learning objectives today. So I'm going to show you how to first of all calculate basic percentages on non-calculator. A few tips and tricks on this. We're going to show you also how to calculate a percentage change using a formula for increasing and decreasing questions, and also how to identify and apply multiplying factors, mainly on calculated papers. But as we said, let's make use of this card. Let's create another space on your card for the best questions you may find useful in this video. And also 3 steps we hopefully get clear at the end of this that will take you to answer any question you want to, or whatever you find useful during this video. Let's create a space for 3 spaces. Step 1, step 2, step 3. Let's turn over to go to our toolkit to find the best methodologies used on this video. So let's now write these 3 clear sections on our toolkit, A, B, and C, and we're going to walk you through the best examples on this topic of basic percentages. So write this down, pause this slide, and let's get ready to go. Question 1, back to basics, basic percentages. Press pause, write these parts down A, B, C, D. This serves as the most basic understanding of this topic. Press play when you're done. So find 10% of 4,000. Now there's something special about this topic. It's about the 10% rule. And the 10% rule is something you should always do for any percentage non-calculators. So the 10% rule basically says, what do? You have an imaginary, let's say, decimal at the end of this. You take it back 1. So from here, we go back 1 and push it over here. Okay, it's a bit messy. There we go. So basically, it's 400.0, which is 400. So 10% is basically, you just take it back 1, the decimal. Okay, it'll just be £400. And that's how easy it is over here. All right, so let's do part B now. So part B says find 10% or £3.50. Same concept. We have our decimal, which is now over here. We're going to take it back 1 over here and put the dot over there. So this is .350. We don't have to put a 0 there, but a 0 always precedes that. This simply reads as 35 pence. So 10% again is 35 pence. And that's simply by just taking the decimal back 1. Okay, next one over here. So 5% of £300. So in this case, let's always do the 10% rule. So it doesn't matter if we have 5%, 6, 7, it doesn't make a difference what the percentage is. Always do 10% first. So 10% is equal to, let's go back 1 with here. We'll go back 1, put the imaginary dot there. It'll be £30. So £30. And we'll put a little box around this just to make sure that this is seen properly. Now once you have this, you can do anything with this. Now 5% would simply be dividing this by 2. Okay, so I'm going to divide that by 2 here, and also divide this by 2 as well. So 5% would be £15. And that's your answer. 5% is your answer, and that was done via the 10% rule, which shows you how important this rule is. So 5% is £15 for this. Next one, we have 1% of £650. So with 1%, you don't actually have to do the 10% rule. It's actually the 1% rule, which works actually. Instead of going back 1, we go back 2. 1, 2. Put a dot over here. This is 6.50 or £6.50. So 1% is straight away going to be £6.50. You go back 2 decimals. That's all you do. Okay, and you don't do anything else. That's all you do. Obviously, to find out 2%, you double it, but that serves as a benchmark. So 10% and 1% are the basic benchmarks on this topic and these core questions to come. But basically, the 10% rule is the key thing to understand. Question 1, cool 1. Press pause, write parts A and B down on question 1 here, and press play when you have finished. So, finding 15% of £520. So the first thing we're going to do is find a 10% rule. This is all non-calculator. So 10% would simply be imaginary decimal point over here. Let's take it back one. It'll be over here. So we have 10% equals £52. Let's put this in a nice rectangle to make sure that this is highlighted. Now we want to find out 5% here, okay? Because 5% is the extra block we need to add this onto. They're like building blocks if you think about it. Okay, so 5% would be half of 10%. We'll divide it by 2. Then we divide this by 2 as well, £26. So let's add them both together. We add them both over here. So 10% plus 5% is 15%. Therefore, 52 plus 26, if you do that over here, we're going to get 2 plus 6 is 8. 5 plus 2 is 7. £78. That would be your answer for this. Okay, so again, look through that. That's quite easy, actually, if you look through it. Part B, Massimo achieves 78% in a test. Sarah scores 27 out of 36 in a test. What is the difference between Massimo and Sarah's result? Okay, so again, non-calculator. Let's see if you work with this idea of two whole numbers and try to find a percentage from this. So we're comparing two different students. Massimo, he's pretty much done. 78%, he scored really well. Sarah, 27 out of 36. So 27 out of 36. Let's do it like this. It's always the smallest over, well, the total, the biggest. 27 over 36. What's the highest common factor that goes into both? Well, I mean, 9 goes into this and 9 goes into this as well. Let's divide each by 9. So how many 9s are in 27? It'll be 3. And how many 9s are 36? 4. 3/4 is 75%. So Sarah scores 75%. And Massimo 78, obviously. So which is better? Or, well, Massimo scored 3% more. But the question is, what is the difference? It's 3%. So the difference is 3%, and that's what they want for the top marks in this. So not bad. These are just introductory kind of questions for this, but again, it serves as a good benchmark for the questions to come over in this topic. Section A, toolkit. So you have just learned the 10% rule, which is very important for non-calculator questions. It's basically just pushing the decimal place back 1 from the far right, okay? Just one space. And once you have the 10% rule, you can do a number of things like finding 5%, creating other building blocks, whatnot. So pause this slide and let's take note of that question we just did. Question 2, core 2. Press pause, write parts A and B down, and press play when you have finished. So Amy's travel commute cost her £1,200 in 2020. And the following year, in 2021, her commute cost her £1,260. What was the percentage increase in her travel cost from 2020 to 21? So this is basically to do with a percentage change, okay? And normally it would say the words percentage increase or percentage decrease, like over here, within the question, okay? And you always deal with two whole numbers as well. So in this case, our two whole numbers are simply going to be this one, 1200 and 1260 as well. Okay, so two whole numbers. Now you need to memorize this formula over here. The formula is for percentage change, difference over initial value. So we'll write this over here. Percentage change equals difference all over initial value and times by 100 as well. Okay, and this is a non-calculator paper as well. So let's put this all in a context, in a nice box. Let's start with this. So what is the difference, first of all, between this? The difference between 1260 and 1200 is simply 60. Okay, so 60 is the difference. If we look at this over here, difference. It's like an equal sign there. Difference over initial value. What do we start with? We started with, in 2020, £1,200. So we have this over this, okay? And we can times that by 100 as well, but don't worry too much about the 100. That will come to us at the end. So first of all, let's cancel a few things out over here. Let's cancel the 0 and the 0 over here. We can divide it by 10 on both sides. So this leaves us with 6 over 120, okay? So again, don't worry about the 100. 6 over 120. Can we break that down? So let's go even further. Let's divide each by the highest factor. That would be 6 in this case. So again, we'll do divided by 6. Divided by 6 as well over here. So 6 and 6. So the final answer would be 1 over, how many 6s are in 120, 20. Okay, now times that 1 and 100. This will give you a 5%. That's something you should know. 1/20th is 5%. So that's how much her commute went up that year. Okay. So look back at that formula. 5%. Right, part B. Sean bought a car for £12,500. The following year, it had decreased to £10,000. So what was the percentage decrease in the value of the car over the year? That's what you want to find out. So let's still apply our context over here. In this case, we're going down, okay? The value has gone down. It shouldn't make a difference whatsoever. So this formula, let's apply over here. So we've got a difference. The difference is £2,500. And that's all over the initial value. We started with, in this case, 12,500. Okay? And that will be times 100 as well. So we're just looking at two whole numbers that give us this idea of using this again, this formula. We're seeing 12,500 and 10,000. And this word as well, percentage decrease opposed to increase. But again, that's what these are the buzzwords. Right, so let's have a look and see how we can do this non-calculator. So let's divide each by 100. We're going to divide this by 100 to cancel the zeros. So we get rid of the zeros over here. Those two go and those two go. So we end up with 25 over 125. Okay, so we have 25 over 125. Let's go even further and break it down. Let's divide each one by the highest factor again, which is 25 and 25 over here. 25, 25. So how many 25s are in 25? That will give us just simply a 1. And how many 25s are in 125? That will give us 5. We times that by 100, and 1/5 you should know 20%. So the car has gone down in value by 20%. That's called depreciation, by the way. It's quite a steep figure. Never buy a first-hand car. Okay, so yeah, that's what you should do over here. Look through those two examples of percentage increase and decrease using your percentage change formula, and know what to look out for when you see this question, i.e. two whole numbers. And it's quite straightforward if you understand this formula over here. So press pause. This is section B here, and let's write down this formula on percentage change. So remember, we use this for percentage increases or decreasing, and when we see two clear whole numbers, or any numbers in fact, in a question. So press pause on this slide, please. Question 3 challenge. Press pause, write parts A, B, and C down on this challenge question on percentages, and press play when you have finished. So part A, Leon has £4,000 in a savings account. So this directly assumes it's a bank. Okay, the interest rate is 2.8% per year. How much does Leon have after 1 year in the savings account? So basically we're dealing with an increasing multiplying factor over here, okay, which is assumed increasing because it's a savings account. It may not be nowadays, but look, it's the best we have, I guess, in this situation over here. So let's see what we have. So the basic setup is this: 4,000. Okay, £4,000. That's your initial value always, how much you initially put into the bank, times by a multiplying factor. Just two things, all right? Initial value times multiplying factor. Now the way we create the multiplying factor, let's say MF for multiplying factor, it's going to be this: 1 plus x over 100. That sounds really complex, but x is just basically your percentage. So if you do the percentage divided by 100, in effect, we're changing this to a decimal. And that is 0.028. So 1 plus 0.028 is actually just going to be 1.028. Okay, this is your multiplying factor over here, 1.028. If you do then 4,000 times 1.028, you're going to get an answer of £4,112. Okay, so this is a clear example of an increasing multiplying factor. And we can just highlight that as a multiplying factor over here, 1.028, 1.028 as well. And that's how we get that. Okay, quite simple. Part B, Alice buys a flat for £150,000. Okay, so here it is. It has decreased in value by 4% over the year. What is the flat worth now? So again, this is an example now of decreasing multiplying factor, okay? Because obviously it's going down in value. So same thing. What's our initial value? It's a £150,000 times our decreasing multiplying factor. What goes in here? Just like this. Now, let's do MF, stands for multiplying factor once again. We'll do 1 take away x over 100. So in this case, x is 4%. So 4 divided by 100 is a 0.04. That's your decimal version. 1 take away 0.04 will be 0.96. So it's very important you take it away from 1 this time instead of adding it, okay? And this is going to be our multiplying factor, 0.96. So 0.96. If you do this, 150,000 times 0.96 on the calculator, you'll get an answer of £144,000. So that's how much a flat is worth after 1 year. So again, it's very crucial you identify a multiplying factor for decreasing, 0.96, 0.96. All right, so we have now had an example of both increasing and decreasing multiplying factors, and that should set you up. Let's just do the last question, part C. So Kobe has run a 12-kilometer race in a marathon. This is only 40% of the whole race. Okay, so we've got basically, let's highlight 12 kilometers and 40%. What is the total distance of the marathon? So 12 kilometers represents 40% of the race. You want to find out the whole entire race. This is not really part of multiplying factors, but it's more of, let's say, think it's a box question. So let's look at the whole of this line like a timeline, okay? And let's see where these numbers fit in. So we will have, let's say, 0 kilometers over here. 40% maybe over here represents 12 kilometers, and this is the finish race, or finish line, should we say. Let's call it X, okay? So X is the X amount of kilometers over here. So this bit over here represents, this bit is 40%, okay? This is 40%, and this whole thing over here is 60%. Let's write that down over here. So this is 40%, and this is 60%. Now, let's just do a common sense approach to this. So if 12 kilometers represents 40%, okay, let's look at this final number here, x. X times 0.4 or 0.40 should give us 12 kilometers, because that's how you find 40% of a specific value. To find out 40% of x, i.e. the final amount, it is 12 kilometers. Let's rearrange this to give us this. X equals 12 over 0.4. On the calculator, this is 30 kilometers. All right, so again, you have to do your homework, and make sure you get this. It's not that difficult. It's a timeline, but I think definitely that timeline does pay off in terms of understanding the whole understanding of this question. Section C on our toolkit. So we have just learned multiplying factors, increasing and decreasing them, and these are your specific formulas for these. Obviously, take these with a pinch of salt in terms of the complexity of them. We outlined some shortcuts of how to actually interpret them in a question. All right, so but write this down. It's good to know this, and press pause on this slide. So here's your revision card and your maths memory card of your 3 key objectives you should have learned during the end of this topic of basic percentages. So the first one, you should be an expert in calculating things like the 10% rule or the 1% rule for basic percentages. You should be able to understand the formula for percentage change, okay, which is difference over initial value given 2 values, and also to identify and apply multiplying factors for both increasing and decreasing. We haven't got any clear steps in this topic because it is quite a big topic in itself, but let's turn over to our toolkit now to see our completed toolkit, so we get ready for our Let's Do It questions. Here is our completed toolkit of sections A, B, and C on this topic of basic percentages. So obviously you have this written down right now. You have part A, the 10% rule, part B, percentage change formula, and part C is going to be your multiplying factors for increasing and decreasing. So
pause this slide and make sure you have all these very good examples and methodologies written down before we hit our Let's Do It questions. Question 1, let's do it. So, write down parts A and B. Let's use our revision cards to best attempt these questions as we go along. So, A and B, press pause and press play when you are ready. Question 2, let's do it. Press pause, write this question down, parts A and B. Press play when you have finished.
Well done, you have now finished this topic of basic percentages. This is week 1, and this is a bronze tier topic, so get back to your revision notes. Make sure you've understood your key concepts during this topic. Simple things of finding out 10%, 5%, 1% of any number whatsoever, 10% rule we called it. Things like multiplying factors, and things like using the percentage change formula as well, difference over initial value. If you've understood this, you've attempted your Let's Do It questions, they're pretty well done, and you've used your cards well to facilitate this. Let's get to our revision planner and rate yourself out of 10, your feel-good factor of how well you feel on this topic.